Tonight we float in silence beside a darkness so large that entire star systems could vanish into it without changing its appearance. You drift at the edge of a supermassive black hole. No spaceship surrounds you. No windows separate you from the view. In this strange bedtime journey, you simply hover there, weightless, watching the universe perform one of its oldest and most mysterious acts. Ahead of you hangs a black sphere darker than darkness itself. Around it swirls a glowing ring of hot gas, bright enough to outshine galaxies. The light bends into impossible shapes. Stars behind the black hole appear above it, below it, and sometimes all around it at once, their paths twisted by gravity like reflections in a cosmic funhouse mirror. It is beautiful. It is unsettling. And somewhere within this vast scene, something impossible is waiting. But first, a small favor. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're here, leave a comment telling me your location and local time. It's always fascinating to see people from all over Earth gathering beneath the same night sky. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The black hole turns slowly before you. Or perhaps it only seems to. One of the strange things about black holes is that they distort your perception of reality itself. Distances become deceptive. Time behaves differently. Light follows curved paths. Even now, as you stare into the darkness, your instincts quietly protest. A black hole should look like a hole. Instead, it looks almost like an object, a presence, a missing piece cut from the universe. This much is established science. Black holes form when enough mass becomes compressed into a small enough region that gravity overwhelms everything else. The boundary surrounding such an object is called the event horizon. Cross that boundary, and according to our current understanding, returning becomes impossible. That fact alone would make black holes among the strangest things in existence. But tonight, something stranger is happening. You notice it first as a faint pulse, a brief flicker, not visible, not audible, more like a subtle rhythm hiding beneath the cosmic scenery. A signal, tiny, regular, persistent. It arrives from somewhere beyond the black hole. At first, you might assume the source is obvious. After all, space is full of signals. Pulsars flash like celestial lighthouses. Quasars pour energy across billions of light years. Galaxies hum with radio waves. The universe is not silent. Yet this signal feels different. Its pulses arrive with extraordinary precision. Tick, pause, tick, pause, tick. As steady as a metronome. As patient as cosmic time itself. You focus on it. The pulses continue. What makes them unsettling is not their existence. It is their location. The source appears to lie far beyond the black hole, somewhere deep within a region of space that astronomers have struggled to understand. A place where observations become uncertain. A place where light itself arrives distorted. A place that should not be broadcasting anything quite like this. The signal has no obvious explanation. And that, surprisingly, is not unusual. The history of astronomy is filled with mysteries that first appeared as tiny anomalies. A star wobbling unexpectedly. A planet moving strangely. A faint radio hiss from empty space. Again and again, major discoveries begin as small irregularities. In 1967, for example, astronomers detected remarkably regular radio pulses from space. The signals were so precise that some researchers jokingly labeled the source LGM, for little green men. Fortunately for science, and perhaps for everyone's sleep schedule, the explanation turned out to be natural. The source was a pulsar, a rapidly rotating neutron star. The joke remains one of astronomy's most famous examples of how mysterious the universe can appear before understanding catches up. And perhaps it's comforting that even professional astronomers occasionally look at the cosmos and think, well, that's weird. The signal before you feels like one of those moments, the kind that begins with curiosity and ends with textbooks being rewritten. Or perhaps not rewritten, perhaps only expanded, because every answer humanity has found about the cosmos seems to reveal a larger question waiting behind it. You continue drifting. The black hole remains motionless. Around it, gas spirals inward at incredible speed. Temperatures rise into millions of degrees. Matter races toward a destination from which no information can escape. Or so we believe. That phrase, or so we believe, appears often in astronomy. Not because scientists lack confidence. Quite the opposite. Science advances by identifying where certainty ends. And black holes occupy one of those boundaries. We understand much about them. Their gravity, their formation, their effects on nearby stars. In 2019, humanity even captured the first direct image of a black hole shadow, confirming predictions made decades earlier. Yet the deepest questions remain unanswered. What happens to information inside? What truly exists at the center? Can gravity and quantum mechanics ever be reconciled? The signal seems connected to those unknowns somehow. You cannot yet explain why. Only that each pulse feels like a breadcrumb leading toward a larger mystery. The stars around you shine steadily. Many of them are ancient. Some began their journeys before Earth existed. Others may already be gone, their light merely finishing a voyage that lasted millions of years. This is one of the universe's most surprising realities. When you look into deep space, you are looking backward in time. The farther away something is, the older the light you see. Astronomy is history conducted with photons. Tonight, that idea will matter, because the signal appears old. Very old. Older than expected. Older than the stars surrounding its apparent source. Perhaps impossibly old. You watch another pulse arrive. Then another. Each one crossing unimaginable distances. Each one carrying information from somewhere beyond easy understanding. You feel no fear. Only wonder. The same wonder that has followed humanity since people first looked upward and asked what the lights above them truly were. The signal continues. Patient. Steady. Unexplained. And somewhere beyond the glowing ring of the black hole, hidden among the deepest reaches of space, the source waits. For now, all you can do is follow. You continue drifting beside the black hole. The signal remains faint but unwavering. Tick. Pause. Tick. Pause. Its rhythm threads through the darkness like a distant lighthouse beam crossing an ocean so vast that even galaxies seem like scattered islands. The source is still hidden. Yet something about it draws you forward. Not physically. Not yet. Instead, your attention begins to travel through time. Because before you can understand a mysterious signal from deep space, you need to understand how humanity learned to listen to the universe at all. For most of human history, the night sky appeared silent. Ancient observers watched stars rise and set. They mapped constellations. They tracked planets wandering across the heavens. They invented myths, calendars, and navigation systems from the motions overhead. But all of this came through visible light. The universe seemed like a grand visual performance. Nobody suspected that the sky might also be speaking. The first step toward hearing it came unexpectedly. In the 19th century, physicists discovered that visible light was only a tiny part of a much larger spectrum. Radio waves, microwaves, infrared radiation, ultraviolet light, X-rays, gamma rays. The cosmos was suddenly revealed to possess many hidden voices. Imagine standing beside a piano your entire life while hearing only one key. Then one day, someone lifts a curtain and reveals 87 more. That was roughly what happened to astronomy. The universe became richer overnight. A scientific fact emerges here. Radio waves are simply another form of electromagnetic radiation, just like visible light, but with much longer wavelengths. That fact transformed everything. By the early 20th century, astronomers began building instruments capable of detecting signals invisible to human eyes. One of the pioneers was Carl Jansky, who in the 1930s detected mysterious radio emissions arriving from the center of the Milky Way. At first, he was trying to improve radio communications. Instead, he accidentally opened an entirely new window onto the cosmos. The universe had been broadcasting all along. Humanity had simply lacked the equipment to hear it. The signal you are following now belongs to that tradition. A whisper crossing impossible distances. A message not necessarily intended for anyone. Merely a phenomenon waiting to be noticed. Ahead, beyond the black hole's distorted silhouette, the pulses continue. As you focus on them, the surrounding stars seem almost secondary. The signal is becoming the story. A surprising observation about the universe is that empty space is not truly empty. Even vast interstellar regions contain particles, magnetic fields, radiation, and ancient echoes from cosmic events. Every direction carries information. The sky is less like a silent vacuum and more like a crowded conversation occurring across billions of years. Most of it goes unnoticed. Then occasionally something unusual appears. Something that refuses to fit expectations. Astronomers have encountered many such mysteries. In 1967, pulsars produced precise signals so regular that their discoverers briefly considered the possibility of intelligent origins before finding a natural explanation. More recently, researchers detected fast radio bursts, brief flashes of radio energy lasting only milliseconds. Some release as much energy in an instant as the sun emits over several days. Many have been traced to exotic objects such as magnetars. Others remain under investigation. The universe continues to surprise even those who study it professionally. And that brings you back to the signal. What makes this one different is not merely its regularity. It is where it seems to come from. The apparent source lies near a region so distant that its light has traveled for billions of years before reaching you. That means the signal may have begun its journey long before Earth formed complex life. Perhaps before multicellular organisms appeared. Perhaps before the first forests. Perhaps before the first animals. The thought is difficult to grasp. You are listening to ancient history arriving in real time. Astronomy often creates this strange feeling. The farther you look outward, the farther backward you see. Light from the moon is about 1 second old. Light from the sun takes roughly 8 minutes to arrive. Light from nearby stars may be years old. Light from distant galaxies can be billions of years old. The night sky is a museum whose exhibits are constantly in motion. The signal pulses again. Tick. Pause. Tick. You begin imagining its journey. The transmission crosses clouds of hydrogen drifting between stars. It passes ancient stellar remnants. It traverses immense voids where galaxies are separated by tens of millions of light years. It survives encounters with magnetic fields, gravitational distortions, and cosmic expansion itself. And somehow it remains recognizable. That persistence feels remarkable, almost stubborn, like a traveler refusing to become lost despite crossing the largest distances nature permits. The black hole behind you gradually recedes as your awareness shifts outward. The glowing accretion disk becomes another point of light among countless others. Yet its presence remains important. Black holes are not merely cosmic curiosities. They are deeply connected to the evolution of galaxies. Evidence suggests that enormous black holes reside at the centers of most large galaxies, including our own. Some contain millions or even billions of times the mass of the Sun. Strangely, their growth appears linked to the growth of their host galaxies. Why this relationship exists remains an active area of research. There is your unresolved mystery for this stretch of the journey. The universe repeatedly reveals hidden connections. Galaxies and black holes. Matter and space-time. Light and gravity. Causes and effects separated by billions of years. The signal may represent another such connection. Or perhaps something entirely different. You continue listening. The pulses feel increasingly deliberate, though you remind yourself that nature often creates patterns without intention. Snowflakes form intricate designs. Planetary orbits establish rhythms. Pulsars keep astonishingly accurate time. Order does not automatically imply purpose. Science teaches caution. Wonder and skepticism travel best together. Still, the mystery deepens. Because as the signal grows clearer, another detail emerges. A subtle irregularity. Tiny. Easy to miss. The spacing between pulses is not perfectly constant. Not quite. Every few hundred beats, a minute shift appears. A fraction of a second. Then another. Then another. The pattern itself seems to contain a larger pattern. Like a melody hidden inside a rhythm. You cannot yet decipher its meaning. Perhaps it means nothing. Perhaps it means everything. Far ahead, beyond clouds of gas and rivers of stars, the source waits in darkness older than civilization, older than humanity, older than memory. And for the first time, you begin to suspect that the signal is not merely traveling through the universe. It may be carrying a clue about the universe itself. The signal remains ahead of you. Not louder. Not brighter. Simply clearer. As though the universe has decided that if you are patient enough, it will reveal one more layer of the mystery. You leave the neighborhood of the supermassive black hole behind. Its warped halo fades into the distance, becoming just another remarkable object among countless remarkable objects. The journey now carries you outward through the deep dark between stars. At first, the emptiness seems absolute. Space has a reputation for being crowded with wonders, but much of it is astonishingly vacant. A surprising observation is that if the Sun were reduced to the size of a marble, the nearest star would still be hundreds of kilometers away on the same scale. The universe is not packed. It is sparse. Enormous stretches of darkness separate even neighboring stars. You drift through one of those regions now. The signal pulses patiently. Tick. Pause. Tick. Its hidden rhythm still contains those tiny irregularities you noticed before. Like a heartbeat within a heartbeat. Like a clock concealing another clock. Ahead, a cloud begins to emerge from the darkness. At first it resembles faint smoke. Then colors appear. Deep reds. Soft blues. Hints of violet. You are approaching a nebula. Nebulae are vast clouds of gas and dust scattered throughout galaxies. Some are stellar nurseries where new stars are born. Others are the remains of stars that died long ago. Science often sounds technical when describing them. Hydrogen, helium, ionized gases, electromagnetic emissions. Yet from nearby, they resemble cosmic watercolor paintings stretching across light years. You drift through glowing filaments. Dust grains float around you. The signal passes through the cloud as effortlessly as moonlight through mist. Its journey never pauses. That persistence is becoming difficult to ignore. For billions of years, whatever created the transmission has continued to influence the cosmos. Or at least that is how it appears. You remind yourself of an important distinction. Observation comes first. Interpretation comes later. The observation is real. A repeating signal. Ancient. Distant. Structured. The interpretation remains uncertain. And uncertainty is where many of the greatest discoveries begin. Beyond the nebula lies another wonder. A neutron star. It appears almost insignificant from a distance. A tiny object suspended in darkness. Yet appearances are deceiving. A neutron star packs more mass than the Sun into a sphere only about 20 kilometers across. A teaspoon of neutron star matter would weigh billions of tons on Earth. That is an established scientific fact, and it remains one of the most astonishing facts in astronomy. You circle the star. Its magnetic fields twist through space. Radiation beams sweep outward. Had this particular neutron star been oriented differently, it might appear as a pulsar, sending regular flashes across the galaxy. The sight reminds you of the first mysterious signals astronomers ever encountered. Signals that briefly inspired speculation about extraterrestrial intelligence before natural explanations emerged. History offers a useful lesson. The universe often appears stranger than expected, but nature usually proves stranger than our first guesses. The signal continues. Tick. Pause. Tick. Now you begin following its path through interstellar space more closely. You imagine each pulse as a traveler. It leaves some ancient source, crosses a galaxy, escapes into the vast regions between galaxies, survives billions of years, and finally reaches observers who evolved around an ordinary star on the edge of an ordinary spiral galaxy. There is something quietly beautiful about that chain of events. The universe does not seem designed for easy communication. Distances are too large. Time scales are too immense. Yet information still finds a way to travel. Light carries stories. Gravity carries stories. Particles carry stories. Reality appears determined to preserve traces of what has happened. At least most of the time. That thought leads naturally toward another mystery. What exactly is information? Physicists use the word constantly. Information about a particle. Information about a star. Information about a black hole. Yet information is strangely abstract. You cannot hold it. You cannot weigh it. And yet modern physics increasingly treats information as something fundamental. Perhaps as fundamental as matter or energy. The significance of that idea will become clearer later. For now, the signal offers only hints. Ahead, the stars begin to thin. You are entering one of the great cosmic voids. These regions are among the largest structures in existence. Some stretch hundreds of millions of light-years across. Galaxies cluster around their edges, leaving enormous volumes with comparatively little inside. From Earth, People often imagine space as mostly empty. The truth is even more extreme. The void surrounding you feels endless. No nearby stars. No glowing nebulae. No bright galactic core. Only darkness. And the signal. The loneliness of the scene should feel unsettling. Instead, it feels peaceful, like standing beside a calm ocean at midnight. The pulses continue arriving. Steady, patient, ancient. Then something changes. Not in the signal itself. In the space around it. You begin mapping the transmission's path more precisely. And a strange pattern emerges. The signal appears to have crossed multiple regions where gravity should have distorted it significantly. Yet the distortions are weaker than expected. Tiny discrepancies. Tiny anomalies. Nothing dramatic. Nothing impossible. Just enough to attract attention. Astronomy has a long history of discoveries beginning this way. A planet found because a star wobbled unexpectedly. Dark matter inferred because galaxies rotated too quickly. Entire theories born from measurements that seemed slightly wrong. The anomalies surrounding the signal are small, but they are real, and they suggest that the source may not be the only mystery involved. Something along the route itself appears unusual. Something hidden. Something affecting gravity. You cannot identify it yet. Neither can anyone else. But for the first time, the mystery feels larger than a distant transmitter. The signal may be pointing toward a deeper feature of the universe. A hidden structure. A missing ingredient. A shadow cast by something humanity has not yet learned to see. Far ahead, beyond the immense void, another region of darkness awaits. And somewhere beyond that darkness, the source continues sending its impossible whisper across cosmic time. The deeper you travel, the less familiar the universe becomes. The stars are farther apart now. The galaxies seem more distant. Even the darkness feels different, as though you have drifted beyond the comfortable neighborhoods of the cosmos and into territory where reality itself begins to reveal its stranger habits. The signal continues ahead. Tick. Pause. Tick. Its ancient rhythm remains unchanged. But the path it follows grows increasingly difficult to explain. The anomalies you noticed in the great void have not disappeared. In fact, they have become more noticeable. Tiny distortions. Subtle deviations. Small enough that an astronomer might initially dismiss them as measurement errors. Yet when enough small mysteries gather together, they stop behaving like accidents. They begin behaving like clues. You continue onward. Ahead, a galaxy emerges from darkness. Its spiral arms stretch across hundreds of thousands of light years. Billions of stars glow within it. Planetary systems circle quietly. Black holes lurk in hidden corners. Civilizations, if any exist there, would see entirely different constellations than those familiar to Earth. Yet despite all its beauty, something about this galaxy appears wrong. Not visibly wrong. Mathematically wrong. This distinction is important. The universe often looks normal long before calculations reveal that something extraordinary is happening. Astronomers discovered this many times throughout history. One of the most famous examples involves galactic rotation. According to gravity as originally understood, stars farther from a galaxy's center should orbit more slowly than stars near the middle. Much like planets in our solar system. Mercury races around the Sun. Neptune moves more leisurely. The farther away you are, the weaker gravity becomes. Simple. Reasonable. Expected. Yet when astronomers measured actual galaxies, they found something astonishing. Outer stars were moving too quickly. Much too quickly. Fast enough that galaxies should have flown apart. But they didn't. Something invisible appeared to be providing additional gravity. This remains one of the greatest scientific mysteries ever discovered. Today, scientists call the unknown ingredient dark matter. The name sounds dramatic, almost like something from a science fiction novel. In reality, it is simply a label for something whose existence is inferred through gravitational effects. We observe what it does. We do not yet know exactly what it is. That distinction matters. Observation first. Explanation second. The signal now appears connected to regions where dark matter may play an important role. Not proven. Not confirmed. Just suggested. The possibility hangs quietly in the background, like a distant shape hidden within fog. You drift farther into the galaxy. Stars pass beneath you. Globular clusters float like ancient lanterns. Some of these clusters are nearly as old as the Milky Way itself. Their stars have been shining for more than 12 billion years. Imagine a light that began its journey before Earth existed in anything resembling its present form. The universe excels at making human timescales feel charmingly small. A surprisingly humbling talent, really. If cosmic history were compressed into a single calendar year, human civilization would appear only during the final seconds before midnight on December 31st, which means the universe spent most of its life doing quite well without meetings, alarm clocks, or online password resets. Perhaps that last point is evidence of cosmic wisdom. The signal pulses again. Tick. Pause. Tick. Then something remarkable happens. You encounter a gravitational lens. This is not a lens made of glass. It is a lens made of gravity. According to Einstein's theory of general relativity, mass bends spacetime. And because light travels through spacetime, light follows those curves. A galaxy, a cluster of galaxies, or a black hole can therefore act like a giant cosmic magnifying glass. This phenomenon is established science. Astronomers observe gravitational lenses regularly. Some produce rings. Some create multiple images of the same object. Others magnify distant galaxies that would otherwise remain invisible. You drift through one now. The stars around you stretch into arcs. Light curves elegantly across space. Entire galaxies appear duplicated. Reality begins to resemble a hall of mirrors constructed by geometry itself. And within those distorted patterns, the signal behaves strangely. Its pulses arrive slightly delayed, then slightly accelerated, then delayed again. This is expected to some extent. Gravity affects the passage of time. A clock near a massive object runs differently than one far away. GPS satellites around Earth must account for these effects to remain accurate. Relativity is not merely theory. It influences technology every day. Yet the signal's variations exceed predictions. Only slightly. But enough. Always enough. The mystery never becomes obvious. It merely becomes harder to ignore. You continue tracing the transmission toward its source. The farther you travel, the more extreme the environments become. A black hole appears ahead. Then another. Then an entire region populated by some of the most energetic phenomena in the universe. Jets of radiation blast outward from galactic centers. Matter spirals into gravitational abysses. Magnetic fields twist across interstellar distances. The cosmos here feels alive with motion. And yet one question begins to dominate everything else. How much of reality are we actually seeing? Dark matter already suggests that visible matter represents only a fraction of the universe. Stars, planets, nebulae, black holes, and galaxies, all the familiar cosmic scenery, account for surprisingly little of the total content of existence. Most of the universe appears hidden, invisible, unidentified. Imagine discovering that every building, mountain, ocean, and continent on Earth represented only a small fraction of the planet's actual substance. That is roughly the situation modern cosmology finds itself in. And now the signal seems to be leading directly toward that hidden majority, toward something concealed beneath the visible universe, something that influences gravity, something that shapes cosmic structures, something whose presence is undeniable, yet whose nature remains unknown. This is where the mystery expands. What began as an unexplained transmission has become something larger. The signal is not merely traveling through strange regions. It appears to be mapping them, highlighting them, almost tracing invisible structures across the cosmos. You cannot yet say why. Perhaps it is coincidence. Perhaps the route only appears meaningful. Science requires caution. Patterns can emerge accidentally. Humans are excellent at finding connections, even when none exist. Yet the possibility lingers. And possibilities are powerful things. Ahead, beyond the gravitational lenses and the black holes, beyond the galaxies and the ancient clusters of stars, lies a region where the hidden architecture of the universe may become visible, or at least visible through its effects. The signal continues toward that darkness, steady, ancient, patient, as though it has been waiting billions of years for someone to notice where it is pointing. The signal no longer feels like a simple transmission. Not because its pulses have changed. They remain steady. Tick. Pause. Tick. The same patient rhythm continues crossing unimaginable distances. What has changed is your understanding. Earlier, you imagined the signal as a message traveling through the universe. Now it seems possible that the universe itself is part of the message. The path matters. The distortions matter. The invisible structures influencing its journey matter. And as you continue deeper into the cosmic dark, a new possibility begins to emerge. The source may not be the strangest thing involved. The route itself may be stranger. Ahead lies a region where galaxies cluster together in enormous chains. These structures stretch across hundreds of millions of light years. From a distance, they resemble luminous threads woven through darkness. Astronomers sometimes describe the arrangement of galaxies as a cosmic web. It is one of the most astonishing discoveries in modern cosmology. The universe is not random on its largest scales. Galaxies gather into filaments. Filaments connect to clusters. Clusters connect to superclusters. Between them lie vast voids. The result resembles a gigantic three-dimensional network spanning the observable universe. A scientific fact. Computer simulations based on gravity and dark matter predicted this web-like structure before observations fully confirmed it. The agreement was one of cosmology's great successes. Yet success often reveals deeper questions. Because although the web can be mapped, much of what shapes it remains invisible. Dark matter appears to provide much of the underlying framework. Galaxies form where invisible concentrations of mass pull ordinary matter together. In a sense, the visible universe may simply illuminate a hidden skeleton. You drift above one of these immense filaments now. Billions of stars shine beneath you. Countless planets orbit quietly. Entire histories unfold unseen. Civilizations may rise and vanish. Species may evolve and disappear. Yet from this perspective, everything looks like tiny sparks decorating a structure far larger than themselves. The signal passes directly through the filament, then through another, then another, and the pattern becomes impossible to ignore. The transmission appears correlated with regions where the invisible architecture of the cosmos is strongest. Not perfectly, not enough to claim certainty, but enough to raise eyebrows. And in astronomy, raised eyebrows often precede major discoveries. You continue onward. The darkness between filaments grows deeper. The signal continues. Then something unusual appears. At first it resembles a faint glow, a diffuse smudge suspended in blackness. Not bright enough to be a galaxy, not compact enough to be a star cluster. It occupies a strange middle ground. The object seems almost reluctant to reveal itself. As you approach, its true nature remains unclear. This is not unusual in astronomy. Many discoveries begin as blurry anomalies. A faint point of light, an unexpected wobble, a suspicious excess of energy. The universe rarely announces its secrets with dramatic fanfare. More often, it whispers. The signal feels like one of those whispers. You study the glow. Its gravitational influence appears larger than expected. Far larger. Matter nearby behaves as though something massive is present. Yet comparatively little visible material can be seen. The discrepancy is striking. Not impossible. Just puzzling. And puzzles are becoming a recurring theme tonight. One possibility involves concentrations of dark matter. Astronomers have observed regions where gravity reveals more mass than telescopes can directly detect. Entire galaxy clusters exhibit this behavior. One famous example demonstrated that invisible mass and visible matter can even become separated during cosmic collisions. The evidence for hidden mass is remarkably strong. The explanation remains incomplete. And that incompleteness sits at the heart of modern cosmology. The signal threads through the region. Its pulses remain unchanged. Yet their path now resembles a map. A trail connecting gravitational anomalies across enormous distances. You begin wondering whether that interpretation is reasonable, or whether your mind is simply imposing order onto randomness. Humans are pattern-seeking creatures. We see faces in clouds, shapes in stars, stories in scattered events. Science advances partly by recognizing patterns, and partly by questioning them. Both skills matter. Without imagination, discoveries never begin. Without skepticism, mistakes never end. The balance between the two is delicate. Ahead, another anomaly appears. Then another. Then another. None are identical. Some involve unusual gravitational behavior. Others contain unexpectedly sparse visible matter. A few exhibit motions that remain difficult to explain fully. Individually, none overturn physics. Collectively, they create an unsettling impression. The universe seems to be hinting at something. Not revealing. Hinting. There is a difference. The greatest cosmic mysteries often unfold this way. Black holes were once mathematical curiosities. Dark matter began as an inconsistency in observations. The accelerating expansion of the universe emerged from measurements that initially surprised researchers. Reality often hides behind small discrepancies. Tiny mismatches between expectation and observation. Tonight's signal appears increasingly entangled with such mismatches. And then comes the most surprising observation yet. You compare the apparent age of the signal with the structures through which it has traveled. Something doesn't align. The transmission appears older than some of the cosmic features influencing it. Not impossible older, but unexpectedly older. The implication is subtle. If correct, the signal may have begun its journey before portions of the large-scale structure currently shaping its path fully developed. That means it has crossed a changing universe. A universe evolving around it. Galaxies forming. Clusters merging. Dark matter gathering. Cosmic architecture gradually assembling itself while the pulses continued onward. Tick. Pause. Tick. The image is strangely beautiful. A single ancient rhythm surviving while billions of years of cosmic history unfold around it. Civilizations could rise and vanish. Stars could ignite and die. Galaxies could collide. Yet the signal would continue, crossing epoch after epoch, like a bottle drifting through an ocean while continents themselves slowly move. And still the source remains hidden. You know more than before. Yet the mystery has grown larger. The transmission is no longer merely unexplained. It seems connected to structures that define the universe on its grandest scales. The question is no longer, what created the signal? Now another question emerges. Why does its path appear woven into the invisible framework of the cosmos itself? Far ahead, beyond the luminous filaments and hidden masses, deeper shadows await. And somewhere within those shadows lies a mystery larger than any single object, perhaps larger than any single galaxy, perhaps larger than the visible universe itself. The farther you travel, the more the visible universe begins to feel like a surface. Not an illusion. Not something unreal. Simply incomplete. Like waves on an ocean whose depths remain unseen. The signal continues through the darkness ahead. Tick. Pause. Tick. Its rhythm remains unchanged, but your perspective does not. You have followed the transmission across nebulae, neutron stars, galaxies, gravitational lenses, and the immense cosmic web itself. Every step has revealed another layer of mystery. And now those layers begin to converge. The invisible structures hinted at earlier no longer feel like background details. They feel central. The signal appears to thread through regions where gravity behaves as though vast amounts of hidden matter are present. You cannot see this matter. No telescope has directly seen it. Yet the evidence for its influence surrounds you. Galaxies rotate too quickly. Galaxy clusters hold together too strongly. Light bends more than visible matter alone can explain. Again and again, observations point toward something unseen. This is one of the defining mysteries of modern science. Dark matter. The name itself carries an almost mythological quality. Yet it is surprisingly modest as scientific terminology. It does not mean scientists know the substance is literally dark. It means they know remarkably little about what it actually is. The label marks a question, not an answer. A scientific fact, based on current cosmological models, ordinary matter. The atoms making up stars, planets, oceans, mountains, trees, and people, accounts for only a small fraction of the universe's total mass energy content. Everything familiar is part of a minority. The realization is difficult to absorb. Imagine discovering that every city, continent, and ocean on Earth represented only a tiny percentage of the planet's true substance. That is roughly how modern cosmology views visible matter. You drift through a region where the effects of dark matter appear especially strong. Nothing unusual is visible. That is the strange part. The mystery announces itself through absence. Gravity reveals something that light refuses to show. The signal passes through the region without hesitation. Tick. Pause. Tick. And once again, the route seems suspiciously meaningful. Not enough for certainty. Enough for curiosity. Far below, galaxies cluster along invisible gravitational pathways. Computer simulations suggest that dark matter helped shape much of the large-scale structure of the cosmos. Without it, galaxies might not have formed as they did. Stars, planets, and perhaps even life itself could have emerged very differently. In a strange sense, the unseen may have helped create everything visible. That idea carries a quiet elegance. The most important ingredient may also be the hardest to detect. The universe enjoys such paradoxes. You continue onward. The darkness deepens, and another mystery begins to emerge from behind the first. Because dark matter is not the only hidden actor in the cosmic story. There is also dark energy. The name sounds similar. The concepts are entirely different. Dark matter appears to pull through gravity. Dark energy appears to push the universe apart. Its discovery shocked astronomers. For much of the 20th century, researchers expected cosmic expansion to be slowing. After all, gravity attracts. Galaxies pull on galaxies. Matter pulls on matter. The expansion left over from the Big Bang should gradually decelerate. That expectation seemed reasonable. Nature disagreed. Observations revealed that cosmic expansion is accelerating. The universe is not merely growing. Its growth is speeding up. Something appears to be driving galaxies apart faster and faster over time. The cause remains uncertain. Dark energy became the placeholder name. Another label attached to another enormous mystery. You glance across the cosmic landscape. Entire clusters of galaxies drift slowly away from one another. Over immense timescales, distances increase. The observable universe changes. The future stretches outward. And the signal continues crossing that expanding space. A surprising observation follows from this expansion. There are regions of the universe so distant that their light may never reach us. Not because they are moving through space too quickly, because space itself expands between us. The cosmos contains horizons beyond which information may forever remain inaccessible. That thought feels oddly appropriate tonight. You are chasing a mystery through a universe that naturally hides things. The signal pulses again. Tick. Pause. Tick. Then you notice something subtle. The anomalies along its path are not random. At least, they no longer appear random. The transmission seems associated not merely with concentrations of hidden mass, but with boundaries, transitions, regions where one cosmic regime gives way to another, dense structures beside vast voids, visible matter beside invisible frameworks, order beside emptiness. The pattern remains tentative, yet it persists, and persistence matters. Many scientific breakthroughs begin when a pattern survives repeated attempts to dismiss it. You continue tracing the route. Ahead lies a region almost entirely devoid of galaxies. One of the great cosmic voids. Its emptiness is staggering. Millions of light-years pass without significant structure. If galaxies are cities, this is a desert larger than imagination comfortably handles. Yet even here, the signal remains. Crossing the void. Ignoring the emptiness. Connecting one distant region to another. The sight creates an unexpected feeling. Not loneliness, Continuity. The pulses seem to stitch together pieces of the universe that would otherwise appear disconnected. A thread crossing darkness. A rhythm surviving distance. And somewhere in that rhythm another question begins to form. Perhaps the signal is not unusual because of what it is. Perhaps it is unusual because of what it reveals. Imagine discovering a trail in a forest. The trail itself may be ordinary. Its significance comes from where it leads. The same possibility now hangs over the transmission. What if the pulses are not the destination? What if they are a guide? A clue pointing toward hidden aspects of reality that were already there? Dark matter, dark energy, invisible structures, gravitational anomalies, cosmic boundaries. One by one, the mysteries seem to converge, and yet none provide a complete answer. That incompleteness is important. Science has not solved these questions. Observations exist. Evidence exists. Models exist. Final explanations do not. The frontier remains open. Ahead, beyond the void, another layer of the mystery waits. Something even larger than dark matter. Something even larger than dark energy. A question not merely about what fills the universe, but about why the universe behaves the way it does at all. The signal continues toward that deeper uncertainty. Steady, ancient, patient, as though it has crossed billions of years not to deliver an answer, but to guide you toward a question humanity has only just begun to ask. The signal carries you onward, not toward certainty, toward scale. Every mystery encountered so far has expanded the horizon rather than narrowed it. The black hole led to gravity. Gravity led to dark matter. Dark matter led to the hidden architecture of the cosmos. And now that architecture points toward something larger still. The fate of the universe itself. Ahead, galaxies drift through darkness like islands separated by oceans of expanding space. From a human perspective, they appear almost motionless. But cosmic time tells a different story. Wait long enough, and entire galaxy clusters rearrange themselves. Wait longer, and the universe transforms. Wait much longer, and even the stars begin to disappear. The signal continues. Tick. Pause. Tick. Its ancient rhythm crosses distances so immense that ordinary intuition struggles to follow. And as you listen, you begin noticing a strange contrast. The signal remains steady. The universe does not. Everything around it changes. Galaxies evolve. Stars ignite and die. Black holes grow. Structures merge. Yet the signal endures. Like a metronome measuring history itself. You drift between two enormous galaxy clusters. Each contains thousands of galaxies. Trillions upon trillions of stars. Countless planets. More possible stories than any civilization could ever record. Yet even these giants are moving apart. The reason traces back to one of the most surprising discoveries in astronomy. In the late 20th century, astronomers studying distant exploding stars found evidence that cosmic expansion is accelerating. Not slowing. Accelerating. The results stunned the scientific community. For decades, gravity had been expected to act like a brake. Instead, the universe seemed to be pressing the accelerator. A scientific fact. The observations were so significant that they eventually earned the researchers involved the Nobel Prize in Physics. The discovery transformed cosmology. Because if expansion is accelerating, then something fundamentally important is missing from our understanding. That missing ingredient became known as dark energy. Unlike dark matter, which appears to gather and pull, dark energy appears associated with space itself. The more space exists, the more influence dark energy seems to exert, at least according to current models. Yet despite decades of study, its true nature remains unknown. One of the largest components of reality remains mysterious. That sentence would have sounded absurd a century ago. Today it is standard cosmology. You continue drifting. The galaxies around you become more distant. Not because you are moving away, because space itself stretches between them. This concept is notoriously difficult to visualize. Many people imagine the universe expanding into something, a larger surrounding space, a cosmic container. Current evidence suggests otherwise. Expansion appears to occur within spacetime itself. Distances increase. The fabric changes. No external room is required. The universe is strange enough without one, which is probably for the best. The cosmos already keeps physicists awake at night without adding extra universes merely for decoration. The signal pulses again. Tick. Pause. Tick. Then another surprising observation emerges. The transmission seems almost indifferent to the expansion around it. Of course, the signal is affected by cosmic expansion. Its wavelengths stretch. Its journey lengthens. Physics demands that. Yet the underlying pattern survives. The rhythm remains recognizable despite billions of years of cosmic change. That persistence feels increasingly symbolic. A thread connecting epochs. A bridge across history. The universe transforms around it. The signal continues. Ahead, you begin imagining the far future. Not millions of years from now. Not billions. Trillions. Quadrillions. Timescales so vast that language becomes uncomfortable. Stars will not shine forever. Even the longest-lived stars eventually exhaust their fuel. Galaxies will evolve. Collisions will reshape cosmic structures. Black holes will continue consuming matter. The familiar night sky of Earth belongs to a temporary era. A beautiful era. A brief era. Cosmologists sometimes call the present period a privileged time for observation. The universe is old enough for complexity, young enough for distant galaxies still to be visible. Future astronomers may inherit a lonelier cosmos. If dark energy continues behaving as expected, distant galaxies will eventually recede beyond observational reach. The universe could become increasingly isolated, a vast archipelago whose islands can no longer see one another. The thought is oddly melancholic, yet also peaceful. Everything changes, even cosmic geography. The signal crosses the darkness ahead, and for a moment, you wonder whether its source somehow relates to these grand questions. Not necessarily as an answer, perhaps as evidence, perhaps as a clue, perhaps simply as a reminder that reality contains patterns we have not yet deciphered. That possibility grows stronger as the anomalies continue. They never become dramatic, never become obvious. The mystery remains subtle, a scientist's favorite kind, large enough to matter, small enough to require patience. You follow the transmission through another immense region of space. The cosmic web stretches around you. Dark matter shapes structure. Dark energy shapes destiny. Visible matter illuminates both. The arrangement feels almost poetic. The things we see depend upon forces we barely understand. Stars shine against a backdrop of hidden realities. Human knowledge often advances this way. First comes observation, then explanation, then deeper questions. The deeper questions are where you find yourself now, because the signal appears older than civilizations, older than planets, older than many galaxies in their current forms. It has crossed an evolving universe, a changing universe, an accelerating universe, and yet it survives, not unchanged, but recognizable, like an echo refusing to fade. Ahead lies another frontier, a question even larger than cosmic expansion, a question reaching back not toward the future, but toward the beginning, toward the earliest moments of existence, toward the time before stars, before galaxies, before black holes, before the cosmic web itself. The signal seems to point in that direction, not literally, conceptually. Its age, its persistence, its path through cosmic history, everything about it begins suggesting a possibility that would once have sounded impossible. What if the mystery is connected not merely to structures within the universe, but to the processes that created the universe we know? The thought hangs quietly in the darkness. The galaxies continue drifting apart. The signal continues pulsing. And somewhere beyond both, hidden near the edge of understanding, waits a question older than the stars themselves. The signal continues. Tick. Pause. Tick. By now, it feels less like a transmission and more like a companion. Not because it speaks. Not because it reveals its purpose. Simply because it has remained with you through every stage of the journey. Across black holes, across galaxies, across invisible structures and expanding space. Always there, always waiting. And now it draws your attention toward the oldest frontier of all, the beginning, or at least what we currently mean when we say, the beginning. Ahead, the familiar universe starts to fade. Not literally. The galaxies still shine. The stars still burn. But your thoughts move beyond them, backward through time, backward through cosmic history, toward an era so ancient that no star yet existed, no planet orbited, no black hole consumed matter, no galaxy stretched its spiral arms across space. There was only a young universe, hot, dense, rapidly changing, a place almost impossible to imagine. One of the most remarkable scientific facts ever discovered is that the universe was once far hotter and denser than it is today. Evidence for this idea comes from many directions, but one of the strongest is the faint glow that fills all of space. The afterglow of the early universe, known as the cosmic microwave background. You drift through that ancient light now. Not visually, conceptually. The radiation surrounds you. It fills every direction. A faint relic from nearly 14 billion years ago. A whisper from a time when the cosmos was only a tiny fraction of its current age. It is among humanity's greatest discoveries. And yet it raises as many questions as it answers. The signal pulses again. Tick. Pause. Tick. Its rhythm seems impossibly calm compared to the violence of the early cosmos. Because the young universe was not peaceful. Temperatures were extraordinary. Energy densities were immense. Particles collided constantly. Reality itself was different. Yet hidden within that chaos lies one of the strangest mysteries in all of science. Cosmic inflation. According to the leading hypothesis, the universe experienced an astonishing burst of expansion during its earliest moments. Not ordinary expansion. Something far more extreme. A tiny region expanded enormously in a fraction of a second. The process may have smoothed the cosmos, explaining why distant regions appear surprisingly similar today. Inflation remains one of the most influential ideas in modern cosmology. Many observations fit its predictions remarkably well. Yet the underlying mechanism remains uncertain. Scientists possess evidence consistent with inflation. The ultimate explanation remains elusive. That distinction matters. Observation and theory are partners. Neither completely replaces the other. You continue drifting backward through imagination and time. The signal remains beside you. Steady. Ancient. Then a surprising thought appears. What if traces of events older than the observable universe still exist? Not necessarily visible traces. Subtle traces. Patterns. Structures. Information. The idea sounds speculative because it is. Current science does not provide evidence that anything existed before the Big Bang in the conventional sense. Yet some theoretical models explore possibilities. Quantum cosmologies. Cyclic universes. Bounce scenarios. Multiverse concepts. These remain areas of investigation rather than established conclusions. The distinction is important. Tonight's journey explores mystery, not certainty. Still, the questions themselves are fascinating. If spacetime emerged from something deeper, what was that deeper reality like? If inflation occurred, what triggered it? Why do the laws of physics possess the values they do? Why does anything exist at all? The signal offers no answers. Only company. Tick. Pause. Tick. You pass through a landscape of possibilities. Some physicists imagine inflation creating countless regions of space with different properties. Others explore quantum descriptions in which spacetime itself emerges from more fundamental structures. Still others seek explanations that do not require such dramatic ideas. No consensus exists. The frontier remains open. And that openness is beautiful. Many people assume science progresses by replacing mystery with certainty. The reality is subtler. Each discovery often reveals larger unknowns. The map expands faster than the territory of understanding. A century ago, dark matter was unknown. Dark energy was unknown. Black holes remained largely theoretical. The cosmic microwave background had not been discovered. Today, those concepts define modern cosmology. What mysteries remain waiting for future generations? The signal seems almost symbolic of that question. An unexplained pattern crossing a universe filled with unexplained patterns. Ahead, the earliest moments of cosmic history blur into uncertainty. Mathematics remains powerful. Observations remain powerful. Yet eventually both encounter limits. Near the beginning, current theories become incomplete. General relativity describes gravity extraordinarily well. Quantum mechanics describes microscopic phenomena extraordinarily well. Combining them fully remains one of the greatest challenges in physics. At extremely high energies, the two frameworks resist easy reconciliation. Somewhere in that tension may lie deeper truths. Or deeper mysteries. Perhaps both. You continue listening. The signal's hidden subpattern, the tiny irregularity nested inside the larger rhythm, has become increasingly noticeable. It still resists interpretation. Yet it no longer feels random. Every few hundred pulses, the sequence shifts. Then returns. Then shifts again. Like an echo embedded inside another echo. You wonder whether it reflects conditions near the source. or interactions accumulated during the journey, or something else entirely. The universe does not volunteer explanations. Patience remains the price of admission. Far ahead, beyond the first stars, beyond the first galaxies, beyond the first black holes, lies a conceptual horizon. Not a place. A boundary of knowledge. Beyond it, speculation grows. Evidence thins. Questions multiply. And strangely, this does not diminish the wonder. It deepens it. Because if the universe were fully solved, the night sky would feel smaller, less mysterious, less alive. Instead, the cosmos remains unfinished from the perspective of understanding. A story whose final chapters remain unwritten. The signal continues crossing that story. Ancient, persistent, unresolved. And as you approach the deepest questions of existence, another realization begins to emerge. Perhaps the mystery is no longer merely about where the signal came from. Perhaps it is about what information itself means in a universe where beginnings remain hidden and endings remain uncertain. That thought waits quietly ahead, like a door opening onto an even deeper darkness. The signal continues. Tick. Pause. Tick. You have followed it across almost everything the cosmos can offer. Black holes, nebulae, neutron stars, galaxies, dark matter, dark energy, the expanding universe, the fading glow of the Big Bang. Each step has revealed a larger mystery hiding behind the previous one. And now, at the edge of what can reasonably be called a cosmic journey, the questions become less physical, not less scientific, simply deeper. The signal remains unexplained, yet the mystery surrounding it has evolved. You are no longer asking only where it came from. You are asking what it means for such a thing to exist at all. Because beneath astronomy lies something even more fundamental. Information. Everything you know about the universe arrives as information. The light from a distant galaxy carries information. The gravity of a black hole carries information. The particles reaching a detector carry information. Even silence can carry information. A surprising observation is that modern physics increasingly treats information as something profoundly important. Not merely a bookkeeping tool. Something woven into the structure of reality itself. This idea appears most dramatically in one of the greatest unsolved problems involving black holes. The information paradox. To understand it, imagine tossing a book into a black hole. The book contains information, words, ideas, patterns. Eventually, the book is destroyed. Its atoms are shredded and absorbed. From the outside, the information appears lost. Yet quantum mechanics strongly suggests that information cannot simply vanish from reality. Somehow it must remain encoded. Somewhere. This creates a conflict. General relativity and quantum theory seem to tell different stories. Resolving that conflict remains one of the central challenges of theoretical physics. And there, quietly waiting in the darkness, sits another unresolved mystery. Does information ever truly disappear? The signal pulses again. Tick. Pause. Tick. The question feels strangely connected to its persistence. After billions of years, after crossing unimaginable distances, the pattern survives. Not perfectly, but recognizably. The universe appears remarkably good at preserving traces of its history. Ancient starlight survives. Gravitational effects survive. Background radiation survives. Perhaps information survives in ways not yet fully understood. You drift through a region where almost nothing is visible. No nearby galaxies. No bright stars. Only darkness and distant points of light. The emptiness creates space for reflection. And naturally, reflection leads toward time. What is time? The question sounds philosophical. It is also scientific. Physics describes time with extraordinary precision. Clocks measure it. Equations use it. Relativity reveals that it flows differently under different conditions. Yet the nature of time itself remains mysterious. You experience time as a sequence. Past, present, future, a continuous unfolding. But many physical laws do not strongly distinguish between forward and backward directions in time. At the deepest levels, the universe appears less concerned with temporal flow than human experience suggests. Why, then, does time seem to move in only one direction? Why do memories point toward the past rather than the future? Why does order become disorder more easily than disorder becomes order? These questions remain active areas of inquiry. The signal feels almost timeless by comparison. Its pulses connect epochs separated by billions of years. Civilizations may have appeared and vanished during its journey. Entire species may have evolved and disappeared. The signal continues. Tick. Pause. Tick. You begin imagining cosmic history compressed into a single moment. Stars forming. Galaxies colliding. Black holes merging. Particles interacting. Life emerging. Observers looking upward and wondering. Everything interconnected through chains of cause and effect stretching across spacetime. The image creates another question. Why does the universe permit understanding at all? This is not a supernatural question. It is an observational one. The laws of nature appear comprehensible enough that conscious beings can discover them. Mathematics describes planetary motion. Mathematics describes atoms. Mathematics describes light, gravity, and expansion. Why should reality possess such structure? No definitive answer exists. Yet the question remains fascinating. The cosmos could have been chaotic beyond comprehension. Instead, patterns emerge. Regularities emerge. Knowledge becomes possible. You are evidence of that possibility. A collection of atoms produced by stellar processes, contemplating the universe that produced those atoms. A surprisingly elegant arrangement when you think about it. Though perhaps the universe could have made the user manual a little clearer. The signal pulses again. Even now, after everything you have seen, its source remains hidden. And perhaps that matters. Mysteries often exert power precisely because they remain unresolved. A solved puzzle becomes knowledge. An unsolved puzzle becomes a frontier. The frontier invites exploration. Ahead lies one final stretch of darkness. Not empty darkness. Meaningful darkness. The kind that appears whenever knowledge reaches its current boundary. You reflect on consciousness itself. The universe contains stars, galaxies, and black holes. Yet it also contains observers capable of wondering about them. Whether consciousness plays any deeper role in cosmic reality remains unknown. Mainstream science does not require consciousness to explain the behavior of stars or galaxies. Yet the existence of conscious observers remains one of nature's most remarkable outcomes. The universe became aware of itself at least in tiny pockets. That fact alone is extraordinary. The signal has traveled across billions of years to arrive at minds capable of noticing it. Whatever its origin, that connection feels meaningful. Not necessarily intentional. Simply meaningful. The cosmos produces patterns. Observers discover patterns. Knowledge grows. Mystery remains. And perhaps both are necessary, because without mystery, curiosity fades. Without curiosity, discovery ends. The signal continues ahead. Steady, ancient, patient, and now you find yourself approaching the final question. Not what the signal says, not even where it came from, but why the universe continues to conceal part of the answer. Beyond the darkness waits the last stage of the journey, the source, or something close enough to it. And with it comes a realization that may be more unsettling and more beautiful than any explanation. The signal continues. Tick. Pause. Tick. After everything you have seen, the rhythm feels familiar now, almost comforting. You followed it from the shadow of a supermassive black hole. You traced it through stellar nurseries and neutron stars. You watched it cross the cosmic web, thread through hidden concentrations of dark matter, and survive the accelerating expansion of the universe. You followed it backward toward the dawn of cosmic history and forward toward questions about information, time, and existence itself. And still the source remains hidden. Or perhaps more accurately, the source remains partly hidden. Because now, at last, you have reached the closest thing this journey offers to an answer. Ahead lies a region unlike any you have encountered before. Not because it glows unusually brightly. Not because gravity behaves impossibly. Not because physics has broken. Quite the opposite. The region appears ordinary. Almost disappointingly ordinary. A sparse area between larger structures. A place an astronomer might easily overlook while searching for something more dramatic. Yet the signal converges here. Its path, reconstructed across billions of years, points unmistakably toward this location. You wait. The pulses continue. Tick. Pause. Tick. And then the realization arrives. Not all at once. Gradually. The way many profound discoveries emerge. The signal never led to a single object. It never pointed toward one extraordinary star, one impossible black hole, or one hidden civilization. Instead, it highlighted relationships, connections, patterns woven through the cosmos. The route mattered more than the destination. The journey mattered more than the endpoint. The transmission appears to be linked to boundaries between known and unknown regions of cosmic structure, to places where visible matter gives way to hidden mass, to places where observation ends and inference begins, to places where certainty fades into mystery. In other words, the signal repeatedly directed attention toward the edges of understanding. The source, whatever it ultimately proves to be, seems less important than the lesson hidden within its path. The universe is not merely composed of objects. It is composed of relationships. Gravity relates matter to spacetime. Light relates the past to the present. Information relates events separated by billions of years. Dark matter relates visible structures to invisible ones. Every mystery you encountered turned out to connect to another. Nothing stood alone. That realization feels strangely beautiful. The signal pulses again. Tick. Pause. Tick. You think back to the beginning. The black hole. Its impossible darkness. The first glimpse of the unexplained rhythm. At the time, the mystery seemed straightforward. Find the source. Solve the puzzle. Reach the answer. Now the answer appears different. The mystery expanded because reality expanded. Each layer revealed a larger context. Each explanation opened a larger question. This pattern appears throughout the history of science. Ancient astronomers learned that Earth is not the center of the solar system. Then they learned the solar system is not the center of the galaxy. Then they learned the galaxy is not the center of the universe. Again and again knowledge grew. Again and again mystery grew with it. A scientific fact remains quietly astonishing. The observable universe contains hundreds of billions, perhaps trillions, of galaxies, each containing vast numbers of stars. And yet, even with all that knowledge, the majority of the universe's content remains unidentified. Dark matter, dark energy, quantum gravity, the origin of cosmic inflation, the nature of spacetime itself. The deepest questions remain open. The signal never changed that truth. It illuminated it. You continue drifting. The darkness around you feels peaceful now. Not threatening. Not empty. Simply vast. A surprising observation occurs to you. The more humanity learns about the universe, the stranger the universe becomes. Black holes turned out to be real. Time turned out to be flexible. Space turned out to expand. Most matter turned out to be invisible. The cosmos repeatedly exceeds expectation. And perhaps that is why the signal feels so fitting. It remains unresolved. Not because science has failed. Because exploration continues. The frontier still exists. Ahead, the apparent source begins to dissolve into uncertainty once more. Measurements blur. Possibilities multiply. The mystery refuses to become final. Part of you might wish for a definitive conclusion. A decoded message. A hidden machine. A cosmic revelation. Instead, the universe offers something quieter. A reminder. Knowledge is not a destination. It is a journey through ever deeper questions. The signal pulses one last time. Tick. Pause. Tick. Then the rhythm seems to blend into the larger rhythms of the cosmos. The rotation of galaxies. The orbit of stars. The evaporation of black holes over unimaginable timescales. The expansion of space itself. Everything becomes part of a larger pattern. You drift in silence. Above you, stars shine. Far away, galaxies turn through the darkness. Black holes shape spacetime with invisible hands. Quantum particles flicker in and out of existence beneath the threshold of direct perception. Cosmic time stretches across billions of years, linking beginnings you cannot fully see to futures you cannot fully imagine. The signal remains unresolved. Yet somehow that feels appropriate, because the greatest discoveries rarely end mystery. They deepen it. You watch the stars. Some are young. Some are ancient. Many will outlive entire civilizations. Their light crosses the darkness patiently, carrying information from one era to another. Beyond them, galaxies gather into vast structures shaped by forces still not fully understood. Dark matter quietly influences their motions. Dark energy quietly influences their destiny. Together they guide the evolution of a universe that remains only partly revealed. Farther still, black holes wait in the hearts of galaxies. Silent, invisible, powerful. Objects once considered impossible, now recognized as fundamental features of reality. Yet even they guard unanswered questions. What happens to information within them? What truly exists beyond the event horizon? What secrets remain hidden in the union of gravity and quantum mechanics? At the smallest scales, quantum particles continue their ceaseless dance. Tiny fluctuations ripple through reality. Probabilities become events. Events become histories. Histories become memories. And somehow, from those microscopic processes, emerge stars, planets, life, consciousness, and curiosity itself. You. A temporary arrangement of ancient atoms contemplating an ancient universe. Around you, cosmic time flows onward. Galaxies evolve. Stars are born. Stars die. Black holes grow. Distances expand. Epoch follows epoch. The story continues. And perhaps that is the deepest lesson of tonight's signal. Not that the universe hides answers, but that it remains larger than any answer. Humanity understands far more than its ancestors ever dreamed possible. We have measured the age of the cosmos, mapped distant galaxies, photographed black holes, detected gravitational waves, explored the quantum world, and still, beyond every horizon, new questions wait. The signal from deep space remains one of them. A whisper crossing billions of years. A reminder that discovery is unfinished. A reminder that mystery survives. A reminder that wonder remains justified. So as the stars continue their slow journeys and the galaxies continue their silent turning, you simply drift, listening, watching, wondering, and somewhere in the immense darkness beyond sight, the universe keeps a few of its oldest secrets. For now, for a little while longer, for anyone willing to keep looking. As the journey fades, allow your attention to soften. Imagine the stars once more, not as distant objects catalogued in databases or measured by telescopes, but as gentle lights scattered across a vast cosmic ocean. Some burn brightly, some glow faintly. All of them participate in a story older than memory. Beyond the stars drift galaxies, spiral galaxies turning slowly through darkness. Elliptical galaxies carrying the accumulated history of countless stellar generations. Entire islands of light separated by distances so enormous that even light itself requires millions or billions of years to cross them. Within those galaxies, black holes rest quietly. Some feed on surrounding matter. Some remain nearly dormant. All continue shaping spacetime, bending paths, influencing futures. They are reminders that nature often hides extraordinary things behind simple appearances. And beneath everything, at scales far smaller than stars or galaxies, quantum particles continue their restless activity. Tiny fluctuations, tiny probabilities, tiny events. The smallest ingredients participating in the largest story. From those particles emerge atoms. From atoms emerge stars. From stars emerge planets. And from planets emerge observers capable of wondering how any of it happened. Above all of this stretches cosmic time, a river wider than imagination, flowing from the earliest moments of the universe toward futures not yet written, carrying galaxies, stars, black holes, particles, and questions along with it. Tonight you followed one of those questions, not to a final answer, to a deeper appreciation of the mystery itself. The signal remains. The universe remains. And somewhere beyond the limits of present understanding, new discoveries wait patiently for future minds. Until then, the stars continue shining. The galaxies continue turning. The black holes continue watching silently from the dark. And cosmic time continues its endless journey forward.